All right, well, good morning, good afternoon, good evening to everybody. We're whenever you're watching the videos, hopefully before. I know you're going to do it before class, but that's what it's designed for. 6.4b is what we're going to talk about today. We're going to do polynomials factoring. We're going to talk about factoring again. Polynomials will be given ax squared plus bx plus c, something in that format. And we're going to use the AC method. 6.4 talks about the AC method, the kind of recipe for factoring and a trinomial of the form ax squared plus bx plus c using a specific set of steps. We're going to do some examples today. All right, so let's go over and look at our 6.4 slide. Again, here's kind of where we've been. 6.2 is factoring when a is equal to 1. That's pretty straightforward. 6.3 is trial and error using a not equal to 1. And the AC method is right here. Sorry, right there are the steps. How to factor ax squared plus bx plus c using the AC method. If you don't have that memorized or in your cheat sheet or your note guide, then definitely put these down. So step number 1, again, write in ascending order, factor out of greatest common factor, factor out of -1 if a is negative, our a term is negative. If it's negative, you have to factor it out. That makes all three of those things makes life a lot easier. Step number 2 is multiply a times c, and you get AC. And that's a product. And then from that product of AC in step number 3, we list factor pairs of AC. That could include negative numbers, so we'll have to pay attention to that. Step number 4 is find the factor pairs from the list in 3. So from those factor pairs of a times c, we'll have to find a pair that adds up to our b term. So here's our b term. We'll have to add it up to that b term. Step number 5 is rewrite the middle term, bx, this in terms of the two factor pairs found in step number 4 above. And then factor by grouping. Pay attention to signs especially, but factor by grouping can sometimes trip people up. And then when you do get a factorization that you say is, here's my factorization, some x plus something, some x plus something, do the FOIL method. Sorry, some x. Do the FOIL method to make sure that you FOIL these two products, or these two factors, to get our product, and that product should be what we start with, ax squared plus bx plus c. Again, page 433 talks about all this here. So if you want to open your book, you might have a list of things that are there. I've modified that just a little bit, especially number 1. All right, so let's go do some examples. We did that one together. That one was homework. So let's go down here and do something like 13w plus 6w squared plus 6. And I just took these, kind of at random, I suppose. So here is a question that we've got. 13w plus 6w squared plus 6. Okay. Step number 1, again, is, I guess, do we have a trinomial with 3 different factors, ax squared plus bx plus c? Sure enough, we do. We've got a squared term and a single, I guess, a variable to the first power and a variable to the 0th power as well. So step number 1 was write it in descending order, factor out of -1, and then factor out a greatest common factor as well. So for this one, we're going to have to rewrite in terms of our ax squared plus bx plus c because it's not in that descending order yet. Our squared term needs to come first. So we need to put 6w squared plus 13w plus 6 is our rewritten factor, or rewritten, product. So that's step number 1. Also, step number 1 is factor out a greatest common factor. There's no greatest common factor here. Step number 1 includes also factoring out a -1 if there's if this a term is negative, but it's not. So from here we can rewrite, or I guess we can pull out a equals 6. There's our a. B equals 13. There's our 13, or our b. C is equal to 6. C equals 6. All right, because that's this 6 here. Step number, let's see, I'm losing track of the numbers here, but step number 2 is multiply a and c to get AC. So here's our a, here's our c. A times c equals 6 times 6 equals 36. All right, now step number 3 is to find factor pairs of 36. And the important thing is, our goal for step 3 and 4 is to find a factor pair over here that adds up to positive 13, adds up to our b term. So with that in mind, we can just start doing factorization of 36. Now 36 factorization could be two negative numbers like -1 times -36 would multiply together to get me positive 36, but -1 times -36 would, if you add up that factor pair, that would add up to a negative number, and we're looking for a positive number. So we should factor out numbers over here that are positive. So factor pairs might be 1 times 36. Does that add up to 13? Nope. 2 times 18. 2 and 18? Nope. 3, oops, sorry, I crossed that one out. 3 times 12. 3 times 12 is 36. 3 plus 12, 13. It's not 13, but we're getting closer. How about 4 times 9? 4 times 9 multiplies together to get 36. 4 plus 9 does give me 36. So there is our factor pair. In fact, I'll probably just circle it in green because I know I'm going to take that over here and rewrite my b term here. So instead of writing 13w, I'm going to write 4w plus 9w and rewrite everything else. I'm going to say this is 6w squared plus 4x, and then the plus 6 falls down as well, because all we're doing in this step here is rewriting that b term here, because here's our b term. Rewrite it. And now we factor by grouping. I forget which step we're on, but factor by grouping. We did step number 4. Step number 5 is rewriting the bx term using the factor pairs that we found. 36 was 4 and 9, and 4 and 9 we rewrote 13 in terms of 4 and 9. Step number 6 now is factor by grouping. So let's go over here and factor this by grouping. Let's group these two together as 6w squared plus 4w, and then we group these last two terms together as well. So now we go back to red and we say, in the red terms that are grouped together, what's a greatest common factor? Well, I see a w, and I also see a 2 because both of these are even. So we put 2w over here, and then we factor 2w out of this this grouping. 6w squared divided by 2w gives me 3w. Plus 4w divided by 2w is plus 2. And now we go over here to blue and we say, for these, what's the greatest common factor? There's no w, but there is a 3, so we can factor out a positive 3. 9w divided by 3 is 3w. Plus 6 divided by 3 is plus 2. And you know you're on the right track when the 3w plus 2 and 3w plus 2 shows up in both of these terms. Because here's a term here, 2w times 3w plus 2 and 3 times 3w plus 2. So this 3w plus 2 and the 3w plus 2 can be factored out as 3w plus 2 times what's left over. Well, really what's left over is this 2w and the plus 3, but really it's 2w times 3w plus 2 divided by 3w plus 2 leaves us what? 2w. 3 times 3w plus 2 divided by 3w plus 2 gives me 3. So there's a plus 3. And that should be our factorization. So in fact, let's circle that in red and say, you know what? I think that's our factorization. But check. Step number 7 was check. So we go back and we FOIL to make sure that we've got our correct factorization. So we start with first terms. 3w times 2w gives us 6w squared. Outside terms, 3w times 3 is plus 9w. Inside terms is plus 4w. Last terms, 2 times 3 is plus 6. Combine the like terms, we'll get 6w squared plus 13w plus 6, which is the same thing as up here in a rewritten form, or up here, I guess. So our 6w squared, 13w, 13w, 6, and 6, you know what? That checks out, so that checks out as well as our factorization. So we started with that, we did that one there. We got to that factorization. That's ultimately the goal of the AC method. All right, let's do another one just for fun. We'll see this one here, 10x cubed minus 85x squared plus 105x. For that one, I'm going to leave you to your own devices. Hang on one second. I'll see if I can move this one up here just to give us a little bit more space. All right, that gives us a little more space. All right, let's do this one here. And that one is our question. Pause the video. Take a look at this. 10x cubed minus 85x squared plus 105x. See if, number one, you can in step number 1, make your life easy, because it's going to make by doing that, probably 2 of those 3 steps, you'll be able to make your life easy. So make your life easy, and then see what you can do with factoring that out using the AC method. Pause the video and let's come back. All right, so we've paused the video. You did some work. Step number 1 would be descending order. X cubed, x squared, x to the first power. Yes, it's in descending order because 3 and 2 and 1 are in descending order. So it's in descending order. Do we have to factor out a -1? We don't have to factor out a -1 from the polynomial because a is not negative, but we do have to factor out a greatest common factor. In this term and this term and this term, I see, let's see, hang on a second. I see a greatest common factor of at least x. But there's also something else. In 10, there's a 2 and a 5. This is not even, so there's no 2 there, but you can pull out a 5 from there and a 5 from there. So let's pull out a greatest common factor of 5x. And then rewrite this original polynomial in terms of a greatest common factor and what's left. All right, so 5x is 10x cubed. Sorry, to rewrite this, we take each individual term, divide by 5x, because we're factoring that out. 10x cubed divided by 5x is 2x squared. Minus 85x squared divided by 5x is minus 17x. Plus 105x divided by 5x is plus 21 nothing. All right, so there is our correct factorization, or there is a factorization. Did we do it correctly? Well, let's do the distributive property and make sure. 5x times 2x squared gives me 10x cubed. Did I say that right? 5x times 2x squared gives us 10x cubed. Yes. 5x times negative 17x gives us the x squared and 50, 60, 70, 85, negative 85x squared, correct. 5x times 21 is 105x. Okay, so our factorization there is correct. So we've now made our life a lot easier because now we've got an a that's all, in fact, all these coefficients here, the numbers are a lot smaller. So if we took a look at the AC method using 10 and 105, we'd get AC equal to 1050. And holy cow, who wants to factor that out in factor pairs and try and match it up to 85? It's going to be a lot easier to use 2 times 21 as our A and C and see what we can go from there, because 2 times 21 in terms of, well, let's see, our A is equal to 2, our B is equal to negative 17, our C is equal to 21, so our AC equals 2 times 21 is 42. Alright, so now to find factor pairs of 42 is a lot easier than finding factor pairs of 1050. And that's the reason that we make our life easier by factoring out that greatest common factor. So here's our AC, and now we've got to find out factor pairs of AC, which is 42, that add up to a negative 17. So now we're going to concentrate on negative factors, because 42 can factor out into positive times a positive, but those positive and positive pairs are going to add up to a positive number. We want a negative number. So we're going to start with just negative numbers. Negative 1 times 42, negative 42. Multiplies together to give me positive 42, not close to negative 17, so that is not a factor pair that we need. Negative 2 times negative 21, closer, but still not negative 17 when we add these up, so throw that one away. Negative 3 and negative 14. How about that one? 3 times 14 is, sorry, negative 3 times negative 14 is positive 42, and negative 3 plus negative 14 is negative 17. So we can rewrite that negative 17x in terms of this one here. So there's our factor pair. That's our magic number that will allow us to split this up. All right, so that said, let's rewrite negative 17x as minus 3x minus 14x, and rewrite everything else that's in the polynomial, 2x squared plus 21. And you notice I'm going to leave something out here. If you noticed it, good for you. If not, I'll bring it up at the very end. So here's my trinomial that I'm factoring out. I got 2x squared, minus 17x is minus 3x minus 14x, because that's our magic number. Plus 21 stays plus 21, and now we've got a 4-term polynomial that we're going to factor by grouping, because now we can start factoring by grouping. So I've got 2x squared minus 3x is a group. The other group of two terms is minus 14x plus 21. And by the way, if you remember from, I think, last video that I talked about, if you got negative 3 and negative 14 are your factor pairs, and you put negative 14 here and negative 3 here, it's not going to make a difference. So don't worry about, should I put the negative 14 here and the negative 14 here? It doesn't really matter, because eventually, if you do it correctly, you're going to get to the same spot. So let's take a look at this now. Let's factor out from the blue pairs. I've got 2x squared minus 3x, and I've got to factor something out of those two terms that's common. I see only an x that can be pulled out. There's an x. 2x squared divided by 2 is 2x. Minus 3x divided by x is minus 3. And there's my factorization of this. You can double check it by saying x times 2x gives me 2x squared. X times negative 3 gives me negative 3x. Looks pretty good. All right, so let's go to the factorization of the next one. What's the factorization of the red? Factorization of the red says look at what's common here. And I'm going to say, well, I'm going to say let's factor out a negative number from here, because we can't factor out an x because this one doesn't have an x. So we're going to have to factor out a number. Let's factor out a number, and I'm going to factor out a negative number, because this 2x over here, eventually what we want to do is find a 2x minus 3 over here if it's possible. So if we're going to find a 2x minus 3 over here in terms of our parentheses, what's left over from the factoring out, then we have to make this negative 14 a positive. So how do we do that? We've got to divide by a negative. So let's factor out a negative. Oops, sorry, I put it in red. Sorry. Factor out a negative 7. And you'll see why. Negative 14x divided by negative 7 is positive 2x. Positive 21 divided by negative 7 is negative. Positive divided by negative is negative. 21 divided by 7 is 3. And the reason I did the factoring out of negative 7 is because when I factor out the negative 7, I get a 2x, a positive 2x, and a minus 3, which is exactly the same factor as over here in this blue term. And now, with that 2x minus 3 common between these two terms, the blue term and the red term, now we can factor out a 2x minus 3. So let's factor out a 2x minus 3 from this term and say, here's my 2x minus 3. And what is this term? X times 2x minus 3 divided by 2x minus 3? That's x. And you got to put this in parentheses now. What is 7? Negative 7 times 2x minus 3 divided by 2x minus 3, because we're factoring that out. That's minus 7. So there's my factorization. I'm assuming this is my factorization because I kind of followed the steps, and this, especially when you get 2x minus 3 and 2x minus 3 as a common factor between the blue and the red terms, you should be on the right path. But let's double check just to make sure. So if we double check, we've got a FOIL. How do we FOIL? Well, first, outside, inside, last. It's that dreaded F word in math. 2x times x is the first term. This gives me 2x squared. Outside terms, 2x times minus 7 minus 14x. Inside terms, minus 3 times x is minus 3x. Last terms, minus 3 times minus 7 plus 21. And now we combine these terms. We get 2x squared minus 17x plus 21, which is exactly what we started with up here in our factorization right up here. So there, this factorization is a correct factorization of this in parentheses. So there, we're all done with our factoring of this trinomial, because that is correctly this is a correct factorization of this. So you noticed, I guess you remember that I said something that I forgot right up in here. I forgot on purpose to write down my 5x. Only because I wanted to concentrate just on this 2x squared minus 17x plus 21, because that's our AC method that we're working with. So if we're concentrating just on the AC method, we follow the steps here, and we got this factorization of 2x minus 3 times x minus 7, which is the factorization of 2x squared minus 17x plus 21. But if we're looking for the factorization of this, because that's our ultimate goal, we have to also include that 5x. So this 5x should go down here, 5x should go down here, and 5x should really go down here. So remember, if you need to, when you factor that out as a greatest common factor, and you say, you know what, I don't want to forget that, you know, at the very end, because I really have to write down my 5x, because our ultimate final answer is this. That should be our final answer. If you need to, when you factor out that 5x as the greatest common factor, write it down 1, 2, 3, you know, 4 times, 3 or 4 times, whatever it takes to remember that, oh, by the way, at the very end, I've got to include that 5x. Go ahead and do that. If you want to remember that 5x comes down as 5x times this in blue parentheses times that red parentheses, and the next step down, you've got to write the 5x times all this stuff here. It kind of gets parentheses. You kind of get parentheses out. So, you might want to, just as a reminder, to you know, if you factor out a greatest common factor, write that down a couple times, and then you won't forget it by the end. All right, we've got a couple more examples. I'm going to say, let's see, you know what? Let's go through some of these together. We'll go through probably one of these together later on in the next video, but we'll come back to that in just a second. Okay, bring your questions to class. Make sure you write down your homework notes. Take a picture, write down the homework question, and submit it to my Dropbox. All right, any questions, bring to class.